Hello everyone and welcome back to today's episode. In today's video, we'll be diving into the heart of a computer to discuss the central processing unit. So if you're a tech newbie or a seasoned pro, having a good understanding of how a CPU works is very essential. So let's dive right in. So let's start by defining a CPU. What is a CPU? Like we've always said on this channel, a CPU is like the brain of your computer. It's responsible for executing instructions on programs and performing calculations. So everything from opening a document to playing a video or editing an image all require the CPU to work. Now, how does the CPU work? Let's break things down. A CPU consists of various components, each playing a crucial role to the performance of the CPU. One of the components is the arithmetic logic unit. This is where all arithmetic and logical operations happen. Think of it as the math genius of the CPU. Then we have the control unit. This unit is responsible for directing the processor on how to handle instruction. It tells the arithmetic logic unit, that's the ALU, the memory, the input and output devices, how to respond to a program's instructions. Then we have registers. Registers are small, fast storage locations on the CPU that temporarily hold data and instruction for the CPU. A typical CPU follows a cycle known as the fetch, decode, and execute cycle. What this means is that the CPU fetches information from the memory, decodes it to understand what actions are needed, and finally executes the instruction. This is known as a cycle. Now let's look at the various types of CPUs. CPUs come in various shapes and sizes, but today we'll be looking at the two main types of CPUs. First off, we have the single core CPU. These CPUs just have a single core with which they process instruction. They are rarely used today as they can only handle one process at a time. An example of a single core processor is the AMD Sempron 150. It was produced in the year 2010 and it has since reached its end of life. The second type of processors we'll be looking at is the multi-core processors. These are modern processors that are built to have multiple cores, with each core handling instructions simultaneously. This kind of processors make them efficient for multitasking. A typical example of a multi-core processor is the AMD Ryzen 7 9800X3D, which was released in the year 2024. Now, when it comes to CPUs, there are certain important terms we need to know, or rather look out for while choosing a CPU. So the first thing we'll be looking at is the CPU core. A CPU core is a single processing unit within a CPU that executes instructions. So the more cores a CPU has, the more tasks it can handle simultaneously. The next thing we'll be looking at is threads. Threads are virtual sequences of instructions given to a CPU. Another term we'll be looking at is multi-threading. Multi-threading allows for better utilization of system resources by splitting tasks into separate threads and running them in parallel. A typical example of where you experience multi-threading is when you're opening a document on your system, browsing the file explorer, browsing the internet, networking, or editing a photo. Then we also have what we call hyper-threading. Hyper-threading increases the performance of the CPU by splitting each core into two logical or virtual processors, which enables it to run tasks simultaneously. Examples of where hyper-threading shine is in tasks like video editing, 3D rendering, scientific and mathematical simulations. Another term we'll be looking at is the clock speed. The clock speed is measured in gigahertz. This indicates how many cycles a CPU can perform in a second. So the higher the clock speed, the faster the CPU. Remember, initially we talked about what a cycle is. A typical CPU performs what we call the fetch, decode, and execute cycle. What this means is that it fetches information from the memory, decodes it to understand what actions are needed, and finally executes the instruction. The more cycles a CPU can execute in a second, the faster the CPU is. We also have the base clock speed and the boost clock speed. The base clock speed is the default speed at which a CPU operates under normal conditions. Then we have the boost clock speed. The boost clock speed is the maximum speed a CPU can can reach for short bursts when more processing power is needed. Then we have the cache. The cache is a small amount of fast memory that is located between the CPU and the RAM. This cache temporarily stores data and instructions that the CPU needs for speedy processing. Then we have the TDP. TDP is an acronym that stands for Thermal Design Power. TDP is the power consumption under maximum theoretical load and is measured in watts. Speaking of CPUs, two of the biggest names in the CPU industry are Intel and AMD. Intel processors are known for their strong single-core performance, making them great for tasks that require a lot of processing power per core. For example, gaming. AMD, on the other hand, offers excellent multi-core performance and is often more affordable, making it a popular choice for tasks like video editing and 3D rendering. So one question I'm sure you will be asking yourself is, what is the right CPU for you? How do you get to choose the right CPU? So when choosing the right CPU, consider what you'll be using your CPU for. If it's for gaming, a CPU with high clock speed and single core performance will be ideal. For multitasking or professional applications like video editing, a multi-core CPU with higher thread counts will serve you better. The future of CPUs is exciting with advancements in technology like quantum computing. These innovations promise even more efficient processors, pushing the boundaries of what our computers can do. So with that being said, thank you so much for watching. I hope this video was able to give you a detailed insight into what a CPU is and how it functions. Don't forget to like, subscribe, and hit the notification bell for more tech insight. Leave your questions and thoughts in the comment section below. We would love to hear from you. Until next time, stay tech savvy.